A nuclear reactor produces power by using the energy released when atoms split apart. That heat is used to make steam. The steam spins a turbine, and the turbine drives a generator that produces electricity. In that basic way, a nuclear power plant is similar to many other power plants. The difference is the source of the heat. Most nuclear reactors use uranium fuel. Uranium atoms are very heavy, and one form, uranium-235, can split when it absorbs a neutron. This splitting is called nuclear fission. When a uranium nucleus splits, it becomes smaller atoms, releases energy as heat, and sends out more neutrons. Those neutrons can hit other uranium nuclei, causing more fissions. This is called a chain reaction. The reactor's job is to control that chain reaction carefully. It must continue steadily, not race out of control and not die away. Fuel rods hold the uranium in solid ceramic pellets. Control rods, often made of materials that absorb neutrons, can be lowered into the reactor core to slow the reaction or raised to let it increase. If too many neutrons are absorbed, fewer fissions happen. If more neutrons are available, the reaction grows. Another important material is the moderator. In many reactors, ordinary water acts as the moderator. Neutrons released by fission are moving very fast, and uranium-235 is more likely to absorb slower neutrons. The moderator slows neutrons down so the chain reaction can continue efficiently. In many designs, the same water also serves as coolant, carrying heat away from the core. That heat is the key product. In a common type called a pressurized water reactor, water flows through the reactor core under high pressure so it does not boil. It becomes very hot, then passes through a steam generator, where it heats a separate loop of water. The second loop turns into steam. The steam rushes through turbine blades, making them spin. The spinning turbine turns a generator, and the generator produces electricity by moving magnetic fields near coils of wire. After leaving the turbine, the steam is cooled back into water in a condenser and used again. The large cooling towers seen at some plants are not nuclear chimneys. They mainly release water vapor and waste heat from the cooling system. Safety depends on controlling heat and radiation. The fuel is sealed inside metal cladding. The reactor vessel is strong steel. The whole system sits inside thick containment structures. Reactors also have backup cooling systems because even after shutdown, the fuel continues producing decay heat from radioactive byproducts. Removing that heat is essential. Nuclear power has advantages and challenges. It can produce large amounts of electricity with very low carbon dioxide emissions during operation. But it also creates radioactive waste that must be managed carefully, and accidents, though rare, can have serious consequences if safety systems fail. A nuclear reactor produces power by turning nuclear binding energy into heat. Fission splits heavy atoms. The chain reaction is controlled by reactor systems, and the heat makes steam to spin turbines. At the electrical outlet, the result looks ordinary. Behind it is one of the most concentrated energy sources humans have learned to use.